Hi, everyone, and welcome to today's session on delivering a better service from your automation solutions. My name is Jennifer Chiswick, and I am the head of product for Atomic Automation Intelligence. Atomic Automation Intelligence is an analytics platform that provides predictive and historical analytics for your automation ecosystem. So today, we're going to be talking about how you can ultimately deliver a better service from your automation solutions. And what I really want to do is take a step back and remind all of us that what we're really doing in this world of automation is delivering a service to our customers. And we all work in the world of automation, or we wouldn't be attending this summit together. And it's a very exciting and fast-paced world. There's a lot of evolving technologies in the world of automation that are interesting to work with. You've got automation solutions that span platforms, mainframe and distributed. You also have solutions that involve automation engines from multiple vendors. You're dealing with scheduling workload on public clouds, on private clouds. There's, exciting containerization technologies that we want to take advantage of, virtualized environments, et cetera, et cetera. There's a lot of exciting components to a full-featured automation solution, and I'm trying to help us not lose sight of the fact that ultimately what we're trying to do is deliver a service. And how can we deliver a service to our customers better? And that will be the focus of today's presentation. So what does it mean to deliver a service better? Deliver it more reliably, deliver it with visibility, so people have a real sense of understanding what the components of the service are and tracking a service, that type of thing. You also want to be able to deliver a service with predictability, to be able to know if your service is progressing in accordance with what you would expect, predicting when it will end and if that end time is actually sufficient. And of course, there's always delivering services faster and cheaper. So these are all things that we're going to talk about, how we can help you accomplish those goals. The last one here is to also be able to confidently deliver changes to a service, because that's an often overlooked area where you have a service that you've been running in one of your automation solutions successfully for some time, and now there's big changes being introduced into that service, so you want to make sure that those can be introduced without disrupting any of the existing services that you currently have in place. So let's look at these one at a time. The first step in delivering a service reliably, which is what we'll talk about, is being able to untangle your business processes. If you want to deliver a service reliably, you really have to know what that service is and who is benefiting from that service, what business process benefits from that service. So inevitably, when you are working with a large, complex automation ecosystem, you've got tens, if not hundreds of thousands of jobs that are part of your automation landscape. And they have relationships with each other. There's dependencies. There's dependencies on jobs from within the same automation engine to external applications, to automation engines running on different platforms, et cetera. And they often have, as I'm sure you're aware, the jobs have extremely cryptic names that don't make much sense to the end user that is ultimately the beneficiary of the business process that's being automated. So the first step to being able to deliver a service reliably is to identify what the service is and to align it with your lines of business. So if you're a financial services organization, you might have lines of business like, finance, equities, online trading, and you want to be able to align your business, your IT processes with those specific lines of business. So that's the first step in delivering it reliably, is aligning it with the actual lines of business that the IT processes serve. Once you've established where your business processes fit in terms of their alignment to the business, we need to talk about establishing service level agreements. Because again, in order to deliver a service reliably, you need to know what the success is. What does reliable mean? This service needs to complete every day by 7:30 p.m., for example. So it's very important to establish SLAs that you can then measure your success against. So through Atomic Automation Intelligence, you can establish those SLAs for your business processes. And in establishing an SLA, it's often very useful to understand historically how has your service performed. Does it typically complete at the same time every day? And how much variance is there? Those are some of the factors that will be involved in establishing a good SLA. Now, sometimes your SLAs are going to be externally driven because your customers are external, and you actually have a hard and fast time that your service needs to be delivered by. That makes it easy to establish your SLA. Oftentimes, they're a little less firm, and there may be an internal SLA. You expect a particular process to complete by a certain time of night because your internal customers want to have their data available by a certain time. So in either case, it's important to establish that SLA time, which will then be used as a success criteria for your business service moving forward. Sometimes you do have services that are running multiple times a day. And in that case, often the SLA would be established based on the duration of that service. So you may have a series of 500 jobs that kick off every 4 hours. And you expect that set of jobs that delivers a service, maybe you're processing trades or something in blocks of 4 hours. You would expect that entire service can complete within 2 hours. So you would have a duration for the service as a whole of 2 hours, and that's what your SLA would be measured against. So it's really an important component in delivering a service successfully, is establishing the SLA. And then, of course, you need to be able to report on how you've done. Have you been able to meet that SLA consistently and with confidence? So it's important to have good historical data with historical reports. You can take a look at a service and look at how it's performed over the last 90 days. How often has it missed the SLA? You may notice certain trends, that it always misses the SLA on Fridays, or it always misses the SLA on the last business day of the month, something like that, that will help you understand how you can improve the reliability of your services. So good historical reports and a good historical data warehouse are key to that, to being able to deliver your service reliably. And one of the very important areas about delivering a service reliably is having visibility into the service. And as you know, with increasing complexity, services are now often spanning multiple workload automation engines across multiple platforms, and also external applications are feeding into the landscape as a whole. So gaining visibility into all of the interrelated parts is critical. So with Atomic Automation Intelligence, we support visibility into multiple different engines, automation engines. And this slide that you're looking at here shows you a list of of the engines that we support today and the ones that have asterisks are all in development, and we expect to have full support for all of those engines within the next 12 months. So you can see that we support CA7 on the mainframe, AutoSys, and Tidal on the distributed side, IBM, IWS, both mainframe and distributed. And support is being added for Atomic, ESP, Control-M, both distributed and mainframe. And I believe I said ESP on the mainframe. So these are all of the automation engines that we support. And what visibility really means is being able to see across these engines in a single pane of glass. So you might have a CA7 mainframe job that kicks off a distributed AutoSys job. It's important to be able to track that across both schedulers and both platforms to know if you're in jeopardy of potentially missing an SLA. So that's just one example. And then often the automation landscape will also include jobs that don't exist in any automation engine. You may have an AutoSys job on the distributed side, and it executes a program that will in fact go and invoke an external application that has its own set of jobs that do not exist inside of any automation engine. And when that group of jobs completes, they will in turn kick off, perhaps a CA7 application. And so you lose visibility when that external application becomes invoked. That could be running for an hour, and there could be 7 or 8 interrelated processes in that external application that you would lose visibility into. So it's important to be able to have a mechanism to bring those black boxes into the landscape and add visibility to them. So that's another feature that we offer within AAI is the ability to bring in and model external applications within your landscape. So this is an example of a particular, it's a little small, so difficult to see, but this is an example of a situation where you might have an AutoSys set of jobs, an AutoSys box, and the last job in the AutoSys box FTPs a file to the mainframe. And that file arrives, that data set arrives on the mainframe, and when it arrives, it then triggers a CA7 job flow, a set of jobs running in CA7. So through AAI, you have visibility into that where you never would see it before. You can track your business process from the very beginning on the distributed side, and if something fails early on your distributed side, you will get a notification that your mainframe SLA is in jeopardy of not being met. So having that type of visibility is really critical to being able to deliver your service, your business service. There's also, dependencies that you may not be aware of between your mainframe and your distributed systems. So discovering those dependencies and modeling them is again critical in supporting this type of visibility. Another area of visibility that's worth mentioning is visibility into the correlation between your job execution and your resource usage. So by resource usage, I mean machine usage. So if you're running in a distributed platform, you have, or even on the mainframe, you'll have jobs that are running on multiple agents across your environment. So how are those agents performing? Do you have one agent that's particularly overloaded? A lot of work is being directed to a particular agent while you have other agents that are sitting idly that could, in fact, be taking some of the load. So visibility into the usage of the resources at the time that the jobs are running is, again, a key analytic to help you deliver your service more efficiently. If you understand that the reason that you're not able to deliver your service is because a particular resource is maxed out during the time that your service is executing, you can take steps to remediate that. So machine or agent usage is certainly one thing you want to look at. Another thing you want to look at is virtualized resources. So within our automation engines, we make use of virtualized resources to help us with some load balancing. You may create a virtual resource with some maximum capacity and not realize that your workload is being throttled and you're not able to meet your SLAs because you're waiting on a virtualized resource to free up. So having visibility into what jobs are using a resource at any given time and the delays that you're anticipating or that you're seeing because of these resource constraints is also a key component of visibility. And as I mentioned before, visibility into external applications is really important. And this is really worth reiterating. You may have, this is a situation where you have a scheduler and a certain set of jobs are running in that scheduler. It could be any mainframe or distributed automation engine. And then that scheduler at some point invokes an external application. That external application runs for some period of time, and then it in turn kicks off another set of jobs within the automation engine. So if you can have visibility into that, you suddenly can connect all of the dots. Whereas before, you would have, according in this screenshot, you would see that there's 3 jobs that run one after another. Then there'd just be some time where you would basically lose visibility. You wouldn't see what was happening in your end-to-end application. So by modeling the external application and connecting it in with your jobs, you now get true end-to-end visibility into your service. And now let's talk a little bit about predictability. So it's critical that as your service is executing, you can predict if it's going to make or miss its SLA. If you can get an early warning that you are in jeopardy of missing a critical SLA, it gives you the valuable time you need to take the steps to fix the problem. So predictability is huge. And predictability, of course, relies on visibility. In order to predict how something is going to behave, you need to first be able to see it. So understanding the components that we just talked about in visibility, which is the dependencies between jobs within a single automation engine, across multiple automation engines, and even including external applications. Once you have that visibility, you can now predict across all of those different variables. So as your business service begins executing, you can predict from platform to platform and through external applications if you're going to be able to make your SLA. So you may have a situation where when your business service starts, you're in good shape. It looks like you're going to finish and you'll beat your SLA by 20 minutes, for example. And then as the service is progressing, you may run into a situation where one job ran a lot longer than it typically does for some reason. And that is going to put you in jeopardy of missing your SLA. So at that point, what you really need to do is recalculate your prediction and see if it's going to miss its SLA at this point. So a dynamic prediction engine which constantly recalibrates and recalculates the prediction based upon the actuals is essential. So again, that's what you'll be seeing with AAI is that as we'll make a prediction based upon all of the historical data that we have and an understanding of all of the relationships between the jobs and the various engines. And if anything runs outside of our prediction, we will immediately recalculate it and update the predictions. And as soon as we predict you're going to miss an SLA, then the alerting mechanism kicks in. And so alerting, of course, is a key component to predictability. You need to be able to get alerts in various ways, email, subscribing through a REST API, SNMP notifications, however you would like. The appropriate people need to be notified as early as possible that you're in jeopardy of missing your SLA. So predictability, again, is a key component. And this also ties back to the very first point we were talking about, which is reliability. And in this case, the predictability is more valuable if it's associated with a line of business. So we may predict that you aren't going to make a certain SLA, and then be able to tell you what lines of business are going to be affected by that. So it ties this predictability directly back to the service that you're delivering to your end user through the line of business. It's often very useful when you're predicting to be able to do some type of what-if analysis. You may know that there's a certain component of the flow that's going to be running in a couple hours that's going to run longer than usual today, because today you unexpectedly had a large volume of transactions that you need to process. And you know that there's a certain component that's going to take twice as long as it usually does. So you want to be able to model that, do a what-if analysis. What if this job runs longer than it typically does? Am I going to make my SLA? So that's another important component to predictability. The other point that's worth mentioning here is a root cause analysis. So if you're predicting, you could even be predicting that you're not going to make your SLA. So there's a status within AAI that we call NPTF, not predicted to finish. So some job, maybe you have a mainframe job that ab-ends. And 5 steps after that job ab-ended, 5 jobs down the dependency chain, that mainframe job kicks off a distributed job. And there's an SLA on the distributed portion of that job stream. So as soon as that job ab-ends on the mainframe, we are in fact going to predict that you're going to miss your SLA. You're never going to reach your SLA on the distributed side. And we will tell you what business areas that's going to affect and what the root cause was. So the root cause of not being able to meet your SLA on the distributed side is because job X on the mainframe ab-ended. And so having that root cause analysis is again critical in being able to timely solve the problem before you actually miss your SLA. And it's as important as it is to predict when your jobs are going to complete and if they're going to make or miss your SLAs. It's also important to predict how your machines will be utilized and how your resources will be utilized. So you may want to take one of your agents out of service for maintenance at a certain time. So if you could predict what jobs will be running on a certain agent machine between 1 and 2 a.m., for example, you may be able to know if that's a good time for you to upgrade an agent or something like that. The same thing is true for resource utilization. If you can predict that you are going to exceed the maximum capacity of a virtual resource, it's very useful to see what jobs are going to be utilizing that resource and either add more capacity to the resource, increase the limit, or move some jobs around to use different resources to allow you to be able to effectively meet your SLA. So that visibility into machine utilization, both historically and predictively, and resource utilization, both historically and predictively, is really key. And then there is this kind of weird idea of how can you predict the unpredictable? because there are certain things that are very difficult to predict. And there is a category of things that are truly unpredictable and can never be predicted, of course. But within the automation engines, there are things that are unpredictable because there's no information within the engine about when something will run. You may have a job that has no starting conditions. It doesn't have any predecessors. It doesn't have any calendaring conditions, meaning it's not scheduled to run on a certain day and time. There's no visible way where you can understand why that job starts, and yet it starts every day at approximately the same time. And once it completes, it then kicks off an entire set of successor jobs to that particular job. So if you can't predict when that first job is going to run, you cannot predict when all of its successors will run. And you really lose visibility, which, as we just talked about, is one of the key components to delivering a service, a workload automation service. So through advanced analytics and some advanced statistics and machine learning algorithms, we can actually look at the patterns of a job's behavior and discern that the job historically on Fridays always runs at 3 o'clock, and on Tuesdays it always runs at 1 o'clock. And based on that historical pattern, we can make a prediction with some degree of confidence that that's what's going to happen with that job today. So again, through applying automation intelligence to your workload automation data, you can make predictions of things that otherwise would be unpredictable. And inevitably, this happens in large complex systems because there's some external application that you may not even be aware of, which is externally triggering a job to start every day, demanding a job in, doing a send event to start a job, something like that, that's happening outside of the scheduling ecosystem, but yet it does happen consistently. So again, through AAI, we can detect those patterns and make the prediction of that job, which then allows us to predict everything that's dependent upon that job. And sometimes you may find that a job is dependent not on a particular time of day, but it's actually dependent on another job. So that you may have a mainframe job that kicks off a distributed job, and you don't really even realize that relationship is there. So by detecting that dependency, you can then predict through it. So predicting the unpredictable is a cool thing. We'll never be 100%. Life is not predictable 100%, but it's an effort to become more and more predictable. So of course, one of the other goals in delivering a business service is to be able to deliver it faster and at less cost. So in order to be able to deliver your services in a shorter amount of time, it's really critical to have good analytics that help you understand why it's taking as long as it is for the service to complete to begin with. And one of the key components to being able to do that is to really understand the critical path through your business service. So the critical path, you can think of it as being the long pole in the tent. This is the set of jobs that take the total amount of time of your business service as a single thread. You may have a business service that represents, that there's 3,000 jobs that need to complete in order for the service to complete successfully. But if you really looked at the critical path, you would find that only a very small percentage of those 3,000 jobs are in the critical path. I mean, they all are critical, they all need to complete, but the ones that are taking the longest time, the ones that are that single thread through the service that's consuming the time, are the jobs that are in the critical path. It may only be 1% of the jobs that are in your large complex job streams. And another important factor about the critical path is that it can change from day to day. You may have a job that runs a lot longer on Fridays, and so on Fridays, it becomes critical path. That job is what's really delaying you from being able to deliver your service on Fridays. So it's really important to understand what that small percentage of jobs are that are taking up the bulk of the time as your business process executes, and understanding what percentage of the time those jobs are in your critical path. That knowledge really is key to being able to optimize and perhaps change the way things are scheduled so that you don't have these bottleneck dependencies. Or maybe you will take one of your jobs that runs a long time, that's in the critical path all the time. Perhaps you can put it on a faster machine and get that job to finish sooner, which would in fact allow you to complete your business service in less time. So without having visibility into the critical path, it's very difficult to know where to focus your optimization efforts. And with having that visibility, it's a lot easier. So good critical path analysis tools, both on an individual job or business service execution, or even aggregated historically, are really key components to being able to optimize your batch. And it's not just the dependencies between the jobs that you care about when you're trying to improve the throughput on a business service. You also want to take a look at virtual resources, for example. So if you have a virtual resource that's at its maximum capacity, that's preventing jobs from running, and those jobs are in your critical path, that's a real typically an easy problem to solve by distributing the work for that job across different virtual resources. There's a lot of different solutions to that problem, but gaining visibility into it is key in order to being able to solve it. To understand that your critical path is being delayed because one of your jobs is waiting on a resource. That's very valuable information. And you can often find that there are jobs that are using the same resources as jobs in your business service that exist in other business services. You may not have been aware of that. So with appropriate analytics, you can see that while your finance application is waiting, it may be waiting on a resource, and that resource is being used by payroll. And you didn't even realize that the payroll system was using the same resource. So gaining that visibility, again, is key. Another factor that often affects the throughput of a business service is design delays. So you may also have designed into your application a delay that maybe you're not aware of. This often happens in complex legacy applications that have just grown large over time, where there's a job that has several predecessors, and it also has, for example, a hard start time. So this job runs when these 3 other jobs complete successfully and at 4 o'clock. Well, if those 3 other jobs have all completed successfully by 2:30, and you're waiting until 4 o'clock to start this job, there's a good chance that delay was unintentional, and that you can gain valuable time in your throughput by removing that delay. Of course, there are certain situations where that hard start time is absolutely required for a business reason, and you can't just remove it. But there are many cases where you may just not be aware of it. It's a legacy, it's a holdover, and it's causing an undue delay in reaching your SLAs. So having good analytics tools to highlight these areas is really essential to being able to deliver your service better. And then there's the issue of delivering changes to a service. This is often a very sticky area. You have a service that's been running efficiently, you're meeting your SLA, everything is great, and you need to upgrade that service. you need to add a new accounting system is being put in place. It's going to mean that you're going to add an extra 500 jobs to an existing application and change dependencies and try to integrate it with other existing components within your production environments. And you want to be able to put those changes into production confidently. It's very difficult to have a test environment that can accurately predict all of these integration changes with your production workload. So one solution that we offer through AAI is to be able to do some simulation and modeling. So what that means is providing to the simulation engine the changes that you're proposing making to your automation, your underlying automation engine. You may want to provide the actual job definitions that you would be implementing into production, along with any anticipated job durations. So you're creating a new job. You're going to add a dependency on an existing job, and you expect that this new job is going to run for 15 minutes. So by providing that information into the simulation engine can then combine the proposed changes with the historical behavior of the production jobs and do a simulation to see if you, in fact, will still be able to meet your SLAs with the proposed changes that you're anticipating. It's a very powerful component, and in the best case, you could integrate that with a DevOps solution. So as you're proposing changes to you're promoting changes to production in your workload automation environments, you can also simulate and model those changes and make sure that they don't breach any SLAs prior to moving them into production as a step of your DevOps process. So that's another area that Atomic Automation Intelligence is working on. We're currently supporting that for our AutoSys scheduler, and we'll be rolling out the simulation and modeling functionality for all of the other automation engines that we support in the near future. So that's something I'm very excited about. And in summary, what I'd like to leave you with today is that the understanding that if you can apply automation intelligence to your automation ecosystem, you can deliver a higher quality service to all of your stakeholders. And that's my goal. Thank you so much for attending the session today, and good luck with implementing your services.